Okay, so as hopefully you all know from reading the press and so on, hackers target the data center. So we've seen several universities have been breached. I know I've had some involvement in one of the big London universities, and again this was from China. We've seen big data centers breached, and obviously I think everyone's probably aware of a large dating service in the data center was breached. But also a lot of these breaches, they wouldn't necessarily breach directly to the data center. They would breach an endpoint, and then would see some kind of lateral spread, and that's typically how people are getting in. They're going to find the weakest link, target the weakest link, which is often the desktop, and then do that lateral spread and work their way through to where the data is they're actually after. In terms of what we're seeing within the enterprise, we're seeing people move from virtual data centers to the hybrid cloud. So what do we mean by that? So the virtual data, as we see it, is your traditional virtualization with things like Hyper-V, VMware, ESXi servers, and so on. So moving away from customers for quite a few years now have moved away from standalone hardware instances to virtualize. But what we're seeing now is the move to more the sort of hybrid cloud, with moving towards the software-defined networking rather than just if you like, the traditional virtualization. So the old data centers, the initial virtualization, tend to be mainly manual operation, perpetual licensing. And what we're seeing now is the move to people want to do more automation and orchestration and pay-as-you-go licensing to fire up application servers and software for short periods of time and then shut them down again. So they're looking for a more flexible, an automated approach to doing that. So in terms of what this new cloud environment looks like, there's obviously still the hypervisor layer, the virtual compute layer. On top of that is the software-defined networking, with a central place to create those networks, define the infrastructure, and bring up those servers and applications. And then a cloud management platform. So one place to orchestrate and automate all the applications. So obviously, as customers move to this new architecture, it brings with it new challenges and new problems to solve. So, as we kind of alluded to in the first slide, what we're starting to see more now is the lateral threats. Spreading laterally across the organization. So I don't know if you're all familiar with the sort of the north, south, east, west traffic flow description. So north, south is basically in and out of your environment. So in and out of the internet effectively. East, west traffic is traffic that stays within your data center or data centers. So the traffic that's moving around within your organization. And the typical figures for that are 20% of traffic is north-south and 80% is east-west. So the majority of traffic is moving around within the organization. So again, when a single machine is breached, there's that lateral threat and lateral spread. And so we need a way to actually start to pick those threats up and monitor what's happening on the east-west traffic as well as the north-south, which the traditional sort of perimeter gateway is there really for north-south, and people still have DMZs and so on, but typically that will go up to your north-south bar back down again. So again, you're creating unnecessary traffic around your internal infrastructure as well. And this lack of security between applications is what's allowing this lateral spread of threats. And as we said earlier, they'll typically attack the lower priority services and then use that as a foothold to move on to the more critical systems. The other challenge we see with the sort of modern data center now is the dynamic changes. So applications are starting up and shutting down fairly quickly. They're short-lived. A lot of the cloud solutions, as well as the on-prem SDN environments, typically use DHCP for services by default. So you'll see machines come up, IPs will change, people will create scaling groups. So as a web farm gets busy, they'll automatically provision new web servers. So again, the whole environment becomes a lot more dynamic, and what would have taken days or weeks to provision now can happen in seconds or minutes. And so the security around that has to change as well. It's just it's the changing environment is too dynamic, and if you can't keep up with that, as well as slowing down the business, you're going to introduce faults and vulnerabilities into the environment. It's also the third challenge really is it's a complex environment. So quite often you've got these environments work very differently, have different interfaces into them. So and quite often you'll have multiple administrators looking after the different areas of the infrastructure. So it's becoming quite a complex environment to manage as well. So what we need from a security perspective is the ability to automate insertion and deployment of advanced threat prevention to protect inside the data center. So what we mean by that is automate that interaction between those dynamic applications and systems starting and pull that into the security platform, so we can pick things up as the environment changes. We can stay on top of it and do it automatically. Same with provisioning, automatic provision as we deploy new systems. We need to provision those into the firewall, and to take advantage of this flexibility, we need to do this quickly. We can't, there's no point in having sort of auto scaling of web farms if you can't auto scale the firewall. It doesn't make sense. You lose the advantage. And most importantly, you've got to maintain that security visibility across your environments. So you still need to have a central place where you can see security across all your estate. You don't want sort of point solutions, because then, as well as being more difficult to manage, you're more likely to introduce faults. You're more likely to miss attacks. So this is where VSec comes in. So it's Check Point's solution for security to protect the modern data center and stay one step ahead of the adversaries. So VSec is split into two elements. Firstly, the VSec Gateway, which is just a virtualized addition, really, of the traditional checkpoint gateway. So with all the protections you're used to, with your sort of IPS blade, your compliance blade, and so on. So the NGTP, NGTX environment within a virtualized solution. Secondly is the VSec controller, which is the way we can actually communicate with the APIs of these different cloud platforms to be able to pull in data and dynamically update the policies and so on as change occurs. So again, just as a recap here, the gateway, we're doing all the firewall, IPS, anti-bot, all the things you're used to on a standard gateway solution. We're doing that in VSec as a virtualized platform. But also in some of the environments where we can, we're also allowing you to secure traffic between the applications. So we're going into, we have the ability to provide sort of full micro segmentation, as it's called. So even when machines, two hosts are on the same subnet, having the ability to send the traffic between those hosts to the checkpoint for analysis. So we can, if you've got 3 web servers, for example, they probably wouldn't normally be talking to each other. They'll be talking to their application server databases and to the consumers using those sites. But you wouldn't expect much traffic between them. So if we, if we cease traffic, if we're monitoring that traffic between those, if a web server gets compromised, for example, and tries to then do some kind of lateral spread, we would see that even where it's on the same subnet through the micro segmentation. The VSec controller, as I said, this is there to automate security within and gives a unified management. and be context aware of policies. You know, I said Azure in here, but we integrate with Azure, with Cisco ACI, and so on. And it also allows us to consolidate logging and reporting across all these different clouds into your existing infrastructure. So by putting in VSEC and enabling the micro-segmentation, we can protect and prevent those lateral threats from spreading within the environment. And again, this is done by the VSEC gateway. So in terms of the platforms we can integrate with Cisco ACI, VMware NSX. So with NSX, for example, we do what's called security service chaining. So with NSX, you create a service chain. So which is effectively like a policy. So when the virtual machine A wants to talk to a virtual machine B, the way NSX works, that traffic doesn't necessarily go through the network. It will go through the hypervisor. It will get through a virtual NIC and the virtual switch from between the two machines. So in order to inspect that traffic, we have to use what's called service chaining, and it's basically using NSX's API to pass the packets to the VSEC appliance. So we can see that the packet would flow from the virtual machine into the VSEC gateway, be analyzed, you know, again, with all the blades that you want to use on there, and then assuming it's clean, it would get passed on to onto the second VM. So again, what the advantages we have here, you know, the legacy networks tend to be quite complex network topologies, whereas with VSEC and SDN micro-segmentation, it's simple, it's agile. So a website may move on a virtual machine from, you know, even between data centers with NSX, and that doesn't matter. We can still follow that. We can still protect that. So although this may be happening, you know, with NSX and VMware, you're going to move machines around based on load of the hardware and so on. So those, and potentially even between data centers, but that's okay because, again, with VSEC, we can follow those. We can still inspect all that traffic. Again, legacy data centers, the threat spreads laterally within the VLAN. I mean, typically you may separate VLANs and onto subnets and push them through the firewall. With SDN and microsegmentation, if you want to, and you know, you don't have to in all cases, but if you want to, then each application can be secured individually, and even traffic between machines on the same subnet can be analyzed. And again, some people may turn this off, and then when there is an incident, again, it's very simple to switch that on to start inspecting all traffic to understand the sort of level of threat that you're seeing. And again, in the traditional data center, the security plans can quickly become the choke point, because typically if you want to separate the networks, the traffic will have to flow up through the infrastructure to the firewall, go through between the zones and back down again. Whereas with SDN, quite often it doesn't even leave the host. So in the case of NSX, for example, we'd have a VSEC instance on every physical server. So as traffic flows between, if it's just staying within the server, it can still flow through a VSEC gateway. So we can still give that level of protection, you know, with the traffic passing between the different applications and servers. And in terms of the hybrid cloud and the public services, we can support VSEC for AWS, VSEC for Azure, VSEC for vCloud Air as well. We're also looking into Google Cloud for probably Q1 next year, depending on the take-up. So pretty much any cloud that out there we can deploy into and give you, that level of protection that you used to with the checkpoint solutions. So the controller, the VSEC controller that I mentioned earlier, although at the moment it's treated as a separate item that you will, longer term it will just become part of the mainstream management station, and it's just a software plugin. It's free. We don't charge for the VSEC controller, and basically this is the plugin that gives us that API capability from your existing management server into VMware NSX or Azure or AWS. So you're still protecting your existing investment in a Checkpoint Smart Center. This is just a plug-in, and say probably next year it'll just become part of the mainstream release as we move forward. Most importantly, across all these environments, your existing Smart Center can manage all those VSEC appliances. So you're still retaining that one point of visibility across your whole estate. So you can pull the logs back, and you can see all the alerts and so on across all the infrastructure. So again, protecting existing investments in your Checkpoint Smart Center, you can use that existing investment to protect the VSEC gateways as if they're just additional appliances out there within your infrastructure. So the automation, some of the automation here is done through having this application-aware policy. So, for example, you'll see in the example policy here, we've imported a finance group from the Cisco SDN controller, and that's been created as an object in the policy. What that means now is we're going to constantly poll. Every 30 seconds we'll poll the controller, and we'll look for a group, for example, where it's a service group. We'll look for new nodes or devices being added to that group. When they get added, we can pull back their IP address, and we can update the policy dynamically. So once you've created, if you want to protect this group and another machine's added to the group, the VSEC controller would pull those details in and automatically push that out to the VSEC gateway. So that protection is automated. You don't have to go through creating a new object, adding it to the group. Equally, if an object is removed, and in these kind of dynamic environments, that's quite important, because at the end of the day, really, we're actually protecting based on the IP address. So if an object is removed and that IP is released, it could then very quickly be reused for something else. So you don't want that to be hanging around in the policy and potentially leaving the machine vulnerable to a policy that doesn't really apply to it anymore. So we will take that. Again, if a machine is removed, we'll take that out. When we get down, if it's the last machine in a group, we're obviously not going to take it out and just leave an any rule. So if it's the final object in that group, we'll disable that rule so that it doesn't apply anymore. So there is obviously control in there to make sure we're not going to do anything that's going to jeopardize the security of the firewall. Equally for NSX, we've got a database group here. I'll quickly go through vCenter here. We've got a single object. Again, that's into the policy. And these objects, we're only polling for the objects that are part of the policy. So we're not going to poll, NSX might have 1,000 objects in there, but we only have 20 in the policy. So they're the ones we're interested in. So we're only going to poll and monitor the 20 that make up the policy, whether that's objects, groups, whatever. So we're only monitoring the objects that have been pulled into the policy. The rest we don't care about because they're not relevant to us. But you can have multiple integrations as basically we're showing in here with different solutions. The other thing we can do with NSX, and we're looking to do this with some of the other platforms as well, is we can pass information back to them as well. So say the anti-bot blade, for example, picks up a machine that's beaking out to the internet as a known malware callback. We can tag that machine has been infected and pass that back to NSX. So NSX can then trigger a reaction, which could be to quarantine the machine. It could be, if it's a web server, it might quarantine it and automatically bring up a replacement. But the key thing here is when we detect that, as well as alerting obviously in your Smart Center console or Adventure or whatever, we can also pass that information back. And NSX can react accordingly based on whatever whatever policy you want to apply for that. It's also worth noting as well here that the security policy is designed for the cloud. So with R80, and I don't know whether many of you have moved to R80 yet, but R80 has sub-policies. So obviously as we're making these dynamic changes, we want to make sure that, well, two things. We're polling and making changes, so we want to be able to have multiple changes occurring at the same time. We don't want, the administrator not be able to look at the policy because it's in the middle of a VMware update. So we can have multiple sub-policies. We can create separate administrators with those to control what can be changed, and we can have multiple administrators accessing the system at the same time. So, as an example here, we can create a sub-policy. So we have a rule here for NSX, controlling what, and the sub-policies below. So 38 is the main policy, and we're saying this applies to anything going to the NSX database group. And then within the sub-policy, we can determine, well, what rules do we want in there. And then the admin that we use for, or the account effectively we're using for polling VMware, has the ability to change these objects, but only within this sub-policy. So again, it's going to stop doing things like adding in any rule, or making the security, weakening the security of the system. So, and again, this is unique to Checkpoint, the ability to have these have multiple administrators with responsibility effectively for just sub-policies, part of the overall policy. So we're able to secure the automation that's happening and keep some kind of control over that, so we're not weakening the overall security stance of the organization. So again, in terms of the products for the SDN, we've got VSEC for NSX, for ACI, for the virtual data center, VE edition, which is I think that's been around a little while, but basically just the standard virtualized version. We do VSEC for OpenStack, and then for the public clouds, AWS, Azure, and vCloud Air. So why VSEC? First reason is this trusted policy delegation. So again, we're one of the few vendors that has the ability to delegate the policy in a secure way. So we can have these multiple administrators with very granular control over what type of policy updates can apply through that automation. Simultaneous updates as well. Again, this is under R80. We have that ability to have multiple administrators, whereas historically, if you were the administrator and you locked the policy while you're working on it, no one else could work on it. Under R80 now, we have this ability to do simultaneous updates and dynamic changes. So as you use VSEC to actually connect to the APIs of these solutions, we can create dynamic changes to the policy. So as things change, as IP addresses change, or nodes get added to a group, we can automatically provision those and deploy. We can deploy that into the policy. So look at just some examples of how you may want to automate. You may want to do automation within the environment. I'll run through just a few examples here. So changing an IP on a web VM, for example. In the traditional method, the application system owner would open a ticket to the firewall admin to change the policy. The policy would be changed, and then at the next change will be approved, and the next change window that will be applied, and that could be days, it could be hours. It's going to take a while. With VSEC and the dynamic updates, when that IP address changes, the VSEC controller will learn about that dynamically and pull that data, pull that change into the policy, and that will be applied immediately to the gateways protecting that environment. Again, changing, adding a machine to a cluster or to a service group. Again, the traditional method would be to open a ticket, to go through the whole change control process there, and the policy will be pushed out in the next change window. But again, with the VSEC controller, we can pick that up automatically when we see it's added to the group. VSEC will learn about it. It will dynamically update, and within 30 seconds to a minute, that is now in there protected, and that additional website is part of the pool, the available pool. Again, changing application networking, developing a manual process for a new database, for example. You manually configure the firewall to secure the new database. Again, this could be a process that takes hours, days. What we can do now with things like vOrchestrate and VMware, you can create an orchestration recipe, so you can define. I have a database. This is the traffic that's going to flow to it. This is how it works, and from that you can push a policy and automatically create a policy from the orchestration tool. So you can deploy the database, you can deploy the policy all automatically, and again, reducing the time down to from hours or days down to seconds or minutes. So enterprises want a single vendor to secure the modern data center, and want the ability for sort of more automation and higher security between the applications. So vSec gives us the ability to do that across all the multiple different environments, cloud environments here. So in summary, vSec will give us the advanced security for the hybrid cloud. It gives us that security automation, and it maintains that unified control and visibility across your whole estate. So that's the end of the presentation. Has anyone got any questions?
Yeah, okay. So it's Darren here. I've got a quick question. How would you typically kind of build that infrastructure with the vSec? Would you run it on virtual machines in the cloud, or?
So if you go, I mean, as an example with Azure, for example,
yeah.
So within Azure, you'd create your VNet, your virtual network. You'll create a number of subnets within there for depending on how you want to split up your environment.
Yeah.
Then you can just deploy vSec from the marketplace. We have two options in Azure. One, bring your own license, which is typically what you'd use. The bring your own license model is obviously more cost effective if it's there for a long period of time. But
right.
equally, you can go for pay as you go if you want. But you can deploy a standalone machine, or you can deploy a cluster, and then once you've got that in place, you can manage that from your existing smart center. So there's a VIP address that similar to a cluster, similar to a normal cluster today, or gateway today. You can connect to it via the VIP address if it's a cluster.
Yeah.
You can then, once you've got up and running, you can just apply your policies, and then you'll route those for Azure, for example. You create user-defined routes, and that will route the traffic from the different subnets through the firewall, so to make sure the traffic flows through the vSec gateway.
Okay, no, that's good because yeah, we're looking at Azure anyway. So so okay, next question then. Would I need some sort of load balancer or something if you're going to have both of these? Presumably you'd want a cluster split different countries, would you, in the Azure cloud, or?
So we don't do in Azure. We only have a cluster within one region. So
okay, yeah.
But Microsoft, if you've got a cluster and availability set within an availability set, as to use sort of Azure terminology,
yeah.
they'll give us sort of something like 4 or 5 nines availability on that. With AWS, you have the option to select zones within each regions, whereas with Azure, it's kind of done for you behind the scenes. So you'll say you want to one in Northern Europe, but that will be potentially spread across different data centers, but that's kind of handled for you in the background. You don't see that. So
okay.
you would only produce that cluster. You deploy it into Northern Europe, for example.
Yep. Okay.
We can then, if you've got networks, VNets in other countries, you can still do peering and route that traffic through that central cluster, or you could deploy multiple clusters and however you want. There's lots of ways of doing it depending on what it is you're trying to achieve, really.
Okay, no, that's great. So how about would you need some sort of load balancer or anything, a software load balancer, or is that something you don't really need? I'm not that familiar with how it works. Really.
So with the way it works with Azure is it is a software load balancer. It will automatically, if you deploy a cluster, it will create a front-end load balancer,
okay.
which is what Azure uses to manage an availability set, as they
right.
call it. So the two files that sit behind the load balancer, and the load balancer then forwards the traffic. At the moment, we're only active passive in Azure, and that's more to do with the way that Azure's designed. That may change in the future. I know they've just released, and this is really all to do with the routing. They have a load balancer at the front, and then we rely on the reason we're only active passive is as the traffic passes through, we route back to the firewall's internal IP. That's the only way to kind of route the traffic back today using a user-defined route. So when the failover occurs, we update the routing table to route to the standby firewall that's now taken over as the master, and at the front, the load balancer will detect the failure and route via the live firewall. One thing Azure have announced recently is this concept of a floating IP, where you can have the same IP across multiple machines. So something like that may allow us to have sort of, you know, active moving forward. But that's not sort of roadmap just yet. So we're going to have to test that and see whether it works in an availability set.
Okay, well, that's great. Okay, thanks for that.
We do have as well in both Azure and AWS, we have the ability where you've got sort of a very, or potentially peaky type website that the traffic's goes up and down a lot. We can create available auto scaling groups. So you can start with, say, 2 firewalls and say you want to limit it to 10, and then Azure will monitor the performance of those firewalls, and when they reach sort of like 80% performance, it will deploy another one and another one up to whatever your limit is. And equally, as it quietens down, it will also automatically remove them and scale down again. So we also have that. You won't find it's not advertised in the marketplace today because it's still on early adoption in Azure. AWS, it's there as standard, so we have that ability to auto scale as well for those kind of environments. Typically, that's more kind of web presences where you're going to have periods where you're going to spike, the traffic's going to spike, and you want to be able to cope with that.
Okay, so have you got a recommended hardware or virtual hardware that does it need to be a dual core virtual machine to run VSEC, or? We'd
recommend a dual core typically a dual core as a minimum.
Yeah.
Beyond that, really, it depends on throughput, so we can give you, as is always the case, what blades you're going to turn on, and what throughput are you using, and we can tell you a machine model whether it's to start. We start with the sort of D2 dual core and kind of go up to whatever you want, really. But there comes a point if we'd go up to probably 4, maybe 8 cores. Beyond that, you're probably better off having additional machines and splitting the load somehow, because we're probably not going to be able to take advantage of 16 cores. It's just the way it works. So there comes a point where you're better off putting more machines in, and as is often the case in the cloud environments, you start to scale laterally rather than vertically. It just makes more sense. Any other questions? Nope. Okay. All right. Well, in that case, I shall stop the